Today on 1 Minute Math, we're going to be talking about rational roots of polynomials. So hopefully you're familiar with this thing called the Rational Roots Theorem. This is a gross-looking theorem, and it probably sounded confusing when you heard about it in class, but it's actually incredibly useful. So the Rational Roots Theorem basically says this, and our goal here, we would be looking at some kind of polynomial. It's got a zillion terms, okay? And we've got this polynomial, and our goal is to try and find the roots, find the zeros, find the x values that will make this equal to 0. Those roots are incredibly helpful to us for lots and lots of reasons. So the Rational Roots Theorem is going to help us find those. And the Rational Roots Theorem says this: every rational root, and rational here meaning like a fraction, anything that could be a whole number or a fraction, is of a polynomial like this is of the form p over q, could be a fraction, where p is a factor of the constant term and q is a factor of the coefficient of the highest power, so the leading coefficient. And we would read this, just so you can see, this is like the generic form of a polynomial. I would read this as an x to the n plus an minus 1 x to the n minus 1 plus dot 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 plus a1 x to the 1, essentially, plus a naught or a 0. A naught would be the fancy way to describe that constant term. Okay, so p over q, p is a factor of the constant term, maybe the constant term, maybe a factor of it. Q is the leading coefficient. I divide them and I get all of the possible factors, all the possible rational roots of this polynomial. Let's see that in practice. What if I was asked, what are all the possible rational roots of this thing? All right, so my factors of 7 are plus and minus 1 and plus and minus 7. My factors of 2 are plus and minus 1 or plus and minus 2. So when I combine those of the form p over q, where p is a factor of the last term and q is a factor of the first term, my possible rational roots would be plus or minus 1 over 1, essentially, plus or minus 1 over 2, plus or minus 7 over 1, and plus or minus 7 over 2. That's it. So of all of the fractions in the whole world, only these 8 could be rational roots. Now, they're not all going to be rational roots. They're not all x values that will make it equal to 0. But if I'm looking for the x values that will make it equal to 0, I only would have to check these 8 numbers. Let's try one of those again, and then we'll see this in the context of a larger problem that might actually feel more satisfying. So this looks really gross, but my factors of 1 are just plus or minus 1. My factors of 3 are plus or minus 1 and plus or minus 3. So the list of possible rational roots of this thing are plus or minus 1 and plus or minus 1/3. The end. Those are the only places where this polynomial could cross or touch the x-axis. Amazing. Now here's the kind of problem where this would be actually handy. Let's say you're asked to completely factor this thing, and you notice it's got an x cubed, and that is the kind of thing that just strikes fear in the hearts of Algebra 2 students. It's got an x cubed, and I cannot pull an x out of every term. What do I do? Well, it would be really handy if I could find at least one root, and then I'd be able to factor that root out, maybe use some synthetic division to get that root out, and then I'd have an x squared thing that I can factor. So let's think about my possible factors here. The possible factors of 11, or negative 11 as it were, are plus or minus 1 and plus or minus 11. The possible factors of 1 are just plus or minus 1. So plus or minus 1 and plus or minus 11 are indeed my only possible rational roots. And I'm just going to start plugging them in until I find something that makes this equation equal to 0. And I'm going to start with positive 1 because that is the easiest one. I'm just going to start at the easiest ones and work up to the hardest ones and see what I get. 1 cubed minus 13 times 1 squared plus 23 times 1 minus 11 would be 1 plus 23 is 24. 13 plus 11 is 24. Well, would you look at that? 1 is a factor, or a 0 rather. X equals 1 is a 0. Fantastic. I'm going to go ahead and delete this guy, all this work, so I can work down here. And now I'm going to factor out that 1. I prefer synthetic division. You might like a different kind of division to pull out a factor, but that's up to you. If you don't understand how to factor larger polynomials or how to pull roots out of polynomials, I've got plenty of videos on that. Just please look them up on my channel and we'll see what we get. But here's synthetic division, especially with a 1. Synthetic division is just real easy. So this number comes up here and I add them. Negative 13 plus 1 is negative 12. pull that number up here. 23 minus 12 is positive 11. Positive 11 plus negative 11 is 0. That's always good when we get a 0 at the end. And I'm just going to put my terms on here. All right. So what this tells me is that my cubic polynomial here could be written as x minus 1, that's that first 0 that I pulled out, times x squared minus 12x plus 11. Oops, I forgot the plus in there. Woohoo! Well, now this looks like something I can factor. And in the end, I'm going to have x minus 1 times, this would give me x minus 1 and x minus 11. And if I simplify that even further, x minus 1 squared times x minus 11. That is my completely factored form of this cubic polynomial. And it was actually fairly painless. I found my actual rational root on the first try, and I was able to use synthetic division and just regular binomial factoring, trinomial factoring to get my final two factors. So I hope you found this helpful. Check out my other videos if you want some help with that factoring of polynomials. See you later.